Sorry, that last video got interrupted. Here's where we were. Sorry, I went to Wolfram Alpha and I switched screens and the computer, my program crashed. But this is what we get from all this. And notice that it's the trapezoid rule approximation is a little bit higher than the midpoint. And this was actually, the integral was a little bit lower, as I recall from class. So this wasn't as good as that. And I want to explore why that is in a second. Okay, so looking back here, we have these error terms. And I just want to look at them briefly. Okay, so for the midpoint, we have the error estimate. And we have the actual error, which is the midpoint error is going to be less than the estimate, and the estimate's going to be equal to b minus a over 3, the max f2 of the function over n squared times 24 for the midpoint, and then the trapezoid estimate, the actual error is less than or equal to the estimate. It's the same thing. Now notice this is twice as small as this. So in other words, this is equal to the trapezoid error is going to be 2 times the estimate for the midpoint, which is 2 times b minus a cubed maximum. Sorry, this is the max. This is the max. And the reason I know that I'm sorry, 24 there. So I'm just recopying this. That's the error estimate for the midpoint. This is the estimate for the trapezoid. That's what I get. Those cancel, and I'm left with the 12. Same things. So the upside is that EM is a better estimate than the estimate for the trapezoid. Sorry, we don't know what the actual error is. The estimate for the midpoint is a better estimate than the estimate for the trapezoid rule. So what I'm going to do is, let's see, I'm going to go and show you, I'm going to actually do these computations. What I did is that I found that the maximum of the second derivative, this is the max of the second derivative of x on 1, 2 is equal to 2.25. So we can do both of these estimates. So I'll do those. So my estimate, this is for the first problem, 1, 2 cosine x over x dx. N is equal to 4, and we saw that the max of the second derivative was 2.25. I calculated that on my own. So then the estimate for the midpoint is b minus a cubed over n squared times 24 times the maximum absolute of the second derivative. Well, that's going to be equal to, actually going to be less than or equal to, well, no, we'll use that as the max. B minus a, 2 minus 1 cubed, 2.25, 4 squared times 24. And what I got for that was about 0.00586. So in other words, well, let's see. I know that my answer was within that much. So my trapezoid, I'm sorry, my midpoint rule answer within 0.00586 of the true answer, which is pretty close. I mean, that's like 5 parts in 10,000. I'm sorry, 5 parts in 1,000. Not too bad. 1 part in 200. Oh, sorry. This was 1, 2. And not too bad. We'll come back and look at that. Now we'll do the same integral. N is equal to 4. Max f double prime of x 2.25, and the estimate for the trapezoid is equal to the same term on top, max f double x over 12 n squared, 2b minus 1a 2.25, that's what I said to use, over 12 times 4 squared. And then when I do the work here, I get about, this is going to be about 0.0117, so that's an approximation. And notice that the estimate for the midpoint was about 0.00586. Multiply this by 2, and you'll get pretty close to that. So you see where that comes from. Okay, that's it. So bottom line, what this tells me is that my trapezoid estimate for this was within about 0.01 of the actual answer. Pretty close, but not as close as this. Okay, thank you.